All right, today we are talking about dilations, our last transformation we need to cover. So we are going to identify and use dilations, but before we get into that, we need to know how to solve proportions. This is an Algebra 1 skill. Really, it's a pre-algebra kind of skill. So I would expect you've seen these before. How do we go about solving proportions? How do we solve it? Not what is the answer. How do we solve these? Okay, so that's one way to logic your way through it. We could see what the numbers are changing by. So we know that we are multiplying 9 times 5 to get 45. We would have to do the same thing on the top. Does anybody remember the other way of solving proportions when you can't see the relationship?
Cross multiplication.
Cross multiplication is the other way of doing that. So we could take 4 times 45 equals 9 times x. Okay, and of course we would then divide both sides by 9. I would rather just cross simplify that to be a 5, and yes, 20 is the correct answer for x. Either way you do it, whether it's you show the relationship or you cross multiply and solve, you should get 20. So what did we get on number 2? Sam? 84. I think that's probably good. So we would take 49 times the 12 equals 7n. When we divide both sides by 7, we could reduce the 49 with the 7, and 7 times 12 gives us the 84. Questions, concerns? We all feel warm and fuzzy about proportions? Okay, our proportions today shouldn't get too much more challenging than these ones, so we should be all right. Couple definitions. First, what is a dilation? Someone was asking that before class started. It's a transformation with scale factor k and center c that maps each point to an image p prime so that the original p is between the center and your scale factor. Basically, your image gets bigger or smaller. You're either going to make your image bigger, which would be an enlargement when you make it larger, or a reduction when you make your image smaller. You reduce it. Remember I talked about the fact that all of our other transformations that we've talked about produce congruent figures? These ones do not. So your pre-image and image are not congruent. Which should be obvious to you when we start looking at them. Not congruent. Questions, concerns, or need more time on this slide? Okay. Up next, we just have to decide if the dilation is a reduction or an enlargement. Now, in my opinion, they add too many lines here, and it makes it look a little more confusing, especially on letter B. So we don't really need these extra lines that they drew right now to connect things. We're just looking at P, Q, R, and P prime Q prime, R prime. So we're really just focusing on these two figures. Remember, the ones without the primes are your originals, and the ones with the primes are the new figures after we dilate. So did our triangle on letter A get bigger or smaller?
Bigger.
It got bigger as we went to the primes, so we would call this an enlargement. Okay, so again, I think all these extra lines that they put in are just a little confusing in this case, but can anybody tell if this is bigger or smaller?
Smaller.
It is smaller. All the primes are on the inside now. We got smaller, so this would be a reduction. Remember, you always start at the plain letters and then go to the primes. Questions, concerns about identifying? On we go. Finding the scale factor is going to be super important to us. When working with dilations, we call the scale factor K. And this is why they put in all those lines, because we need to know these distances. So capital C, does anybody remember what that stands for? It was in our notes just above. Scale factor's K. C was our center. Okay, so C is the center point, which does not necessarily mean that it's in the middle. C is usually going to be off to the side. C would be in the middle if we were looking at this as if it were like a telescope or something. You're looking down the center of one of your triangles, but usually they'll show it to us with C off to the side. So this represents the distance from the center to a new point divided by or over the center to its old point. This scale factor is going to be the same ratio of the lengths of the new sides to the old sides. So if you want to label these things, new point, this would be an old point or an original point. This would be a new side length. Oh, that didn't fit there very well.
Wait, do we have to write that down?
This would go in the box down at the bottom of the front page. This would represent an old side. Okay, so the notation here gets a little bogged down, but once we start looking at examples, if you remember things like new goes on top, old goes on bottom, then you should be okay. Okay, I'm hearing people flip. Are we ready to keep going? Anybody need more time? Okay. On we go. So we are asked just to find the scale factor of the dilation. So they kind of walk us through it a little bit down here. We need to find the ratio of CP prime to CP. So what is the distance from the center to P prime? 2. That goes on top over the distance from C to P. 3. That's all that we need to do in order to find the scale factor. One thing you can do to check if your scale factor is reasonable is to see whether or not this is an enlargement or a reduction. So do we think that this example shows an enlargement or a reduction? A reduction, which means that our scale factor should be a number less than 1. If we made it smaller, we're taking some fraction of it. And 2/3, of course, is less than 1, so we know we must be on the right track. On letter B, what is the distance from C to P prime? 6 over the distance from C to P. 3, and 6 over 3 would reduce to be what? 2 over 1. If you just put a 2, I would be okay with that. 2 over 1 is more accurate since it shows a whole ratio. And again, this time, did we have a reduction or an enlargement? Enlargement, so our scale factor should be bigger than 1. If we're making it bigger, scale factor bigger than 1. Questions about finding scale factors? Okay, once we find them, then we're able to use them. They don't want us to use them yet, though. They want you to try this. Tell if it's a reduction or enlargement. Find the scale factor. So I'm going to pause for a moment while you do that. This is like combining the first example with the second example all into one problem. All right, on this first one, was it a reduction or enlargement? Good, it got bigger. It's an enlargement. Okay, then we had to find our scale factor. What is it? 10 over 5 is what I was looking for, which would reduce to 2 over 1. It's okay. So, remember.
How is it 2 over 1 when it's...
Let's talk about it. Calm down. So, when we find a scale factor, on top, we go from C to where? P prime. C to P prime is 10. On the bottom, we go from C to P, which is 10 divided by 5 is... So 2 over 1, or just 2, would be the appropriate scale factor. Questions, concerns? Okay. Now, I am not a fan of how they drew this because it looks like you got some sort of square going on. But really, we're looking at these two triangles. Okay, that's the idea here. So, is this a reduction or an enlargement? It is a reduction. If it's a reduction, we should expect our scale factor to be some fraction less than 1. What did we get as our scale factor? 1/3. We go from the center to P prime, or a new point. That's 8. Over C to an old point. That's 24. That reduces to 1/3. Make sure you're checking your scale factor to what you said the dilation was. If you said it was an enlargement, you better be multiplying it by some number bigger than 1 if you're trying to make it bigger. If you multiply by a fraction, you're actually making a number smaller. So that's when we have a reduction. Questions before we keep going? Okay. I'm not a fan of how this came out all squished, but that's all right. We can do it anyway. We are told that P prime, Q prime, R prime is the image of triangle PQR after a reduction. Find the value of X. So the first thing they want us to do is see if we can write a proportion using our scale factor. So what is C to P prime? Man. Okay. Hard for me to get out. What about C to P? Okay. 8 over 14. Oh, I think that's what they wanted on the other one. That's what they want below is 8 over 14, which is fine. So here, they're wanting us to fill in the rest of that proportion from our scale factor box. So they're wanting us to compare a new side to an old side. This is not something that I would usually have you write out when we are doing this on an example. I'd usually have you go straight to the second step. But their new side that they labeled was Q prime, R prime, and the old side they labeled was QR. So that's what they really want in that first step. When we substitute, they want to know then, what did they label Q prime, R prime? 6. What about QR? X, right? QR is up at the top. Okay, I'm going to write the rest of this off to the side because I'm having trouble fitting it on these squished lines. When we cross multiply here, notice that there's not a straight relationship that we know off the top of our heads between 8 and 6. So we have to cross multiply. When we do that, we would take 8 times what? Set it equal to what times what? 6 times 14. And then they just want us to solve this. So 8x equals 84. And then we would have to divide by 8. What do we get for x? Okay, it's not going to come out nice, so we could write it as 10.5 is fine for me. If you wanted to write it as a fraction that's reduced, that would also be okay. 21 over 2 or something. But x equals 10.5 works. Okay, so this one set us up and walked us through all the steps. What's important when we do this is to first identify your scale factor, which we've practiced a few times, and then remember that you are comparing a new side on top to an old side on bottom. New on top, old on bottom. So let's try it again. First, we need to know our scale factor. This time, they didn't label the ones by the P, but that's fine. Instead, they labeled the ones to these points down here. So if you would rather think about your P prime and your P being down here instead of at the top, that's okay. So if we're just setting up our scale factor, what do you think it's going to be? 20 over 8. So we go from the center to a new point. That would be 20. Over from the center to an old point. That would be the 8. Questions about the scale factor?
So every time it's like the number inside the little round like that, they go on the top. That's the number.
Not necessarily. It depends on if we're doing a reduction or an enlargement. So we go from C to a new point. The new points happen to be out here. And we go from C to an old point. So it just depends on how they set it up, whether the new point is bigger or smaller. Then we want to compare two sides. On top, we want a new side length. What did they label a new side length with?
2.
How do we know which figure is new and which one's old? The prime. So, is our new figure the bigger one or the smaller one? The bigger one. What did they label one of those sides with? An M. So that is a new side. What about an old side that would correspond with it? 2. Questions about getting our proportion set up. Now we just have to cross multiply or solve it somehow. I am a fan of the cross multiplying. We take 8 times m and set that equal to what? 20 times 2. Okay, of course we know 20 times 2 is 40. Last step to get m alone. And we get m equals 5. If our dilation is an enlargement, we made it bigger, you should expect your m to come out bigger than a 2. Just makes sense. Are we ready to try this again? Okay, this one is a little bit different because they didn't really give us any of our C to a point numbers. You see that? All of these ones that come from C are left totally blank. So this one, we have to set up our proportion just using sides. What kind of sides go on top? New or old? New. So we want new sides on top, old sides on bottom, but we have to match them up. So give me a new side length that they labeled. N is one of our new ones because it's on the figure with the P prime. N corresponds to what old side? The 4, the one that it came from. Okay, what about another new side? 3 over its old side. Good. Now this one you might be able to look at and just know what N is right away. Oop, I didn't mean to put an equals there. 6N equals 4 times 3. 6N equals 12. What is N going to be? 2. Okay, so the whole idea here is you have to set up your lengths new over old. New over old. Questions, concerns?
Wait, would that be reduction?
This is a reduction, yes, because it got smaller. Nothing? We feel like we're ready to practice this on our own? Okay. One other thing I do want to tell you real quick that's not in here, but it is going to be on your project. So let me just get a blank slide up here. You might want to add this to the bottom of your notes because you will see this in your project. So what we didn't talk about is if we have coordinates involved. So let's just say we have coordinates A, B, and C. Somebody give me some coordinates for A. 2, 1. Okay, somebody else give me some coordinates for B. 3, negative 2. Okay, and C? 0, 0. Fine. It doesn't matter to me. Pick 3 coordinates. Dilations are, in my opinion, the easiest things to transform with coordinate notation. So if I were to give you the directions, dilate by a scale factor, I'm going to use SF, scale factor of 5. If I'm dilating by a scale factor of 5, do you think I'm making this bigger or smaller?
Bigger.
Bigger, because my scale factor is bigger than 1. And all we have to do is multiply every single number by 5. That's all you got to do. So A prime is going to be where? 10, 5. What about B prime? 15, negative 10. And C prime?
0, 0.
Stays at 0, 0 in that case. Okay, so on your homework, you probably won't see this because it wasn't part of the notes. However, on your project that we are going to get assigned tomorrow, you might see dilations on there. Now, there are also some dilations where you do reduce it. So if we were to dilate by a scale factor of 1/2, multiplying by 1/2 is the same as doing what? Dividing by 2. So if that were our directions, then A prime would be at 1, 1/2. B prime would be at 1.5 or 3/2, -1. C prime would still be at 0, 0. Okay, so your project, you could see ones where you make it bigger when you've got a scale factor bigger than 1, or you might see them where you make them smaller. Your scale factor is smaller than 1. Questions about coordinate notation and dilating? No. Okay, the rules on that are pretty straightforward, so that's why we didn't have a ton of examples, but you will see it a couple times on that project.